Hello guys, good afternoon, and we're going to talk about the work systems and how they work, more important around the manual work and working machine systems. And later on we will talk about other classes around the workflow, manual assembly systems, workflow and batch processing. But let's get to it. Let's talk about now the manual work and worker machine systems. This is pretty much the observation on some manual work, and then we're going to work with the observations of machine systems and then the automated system. So there are basically three categories of work systems is the manual, like I said, and worker machine system, and then we have the automated work system. So obviously we need to get very good at evaluating the manual system before we move into mechanization and automation. Most of the problems have been in understanding the current work systems in the manual process, and then people jump into automation. But let's say for the manual work systems, you have hand tools, you have the worker, and you have the start working unit or the material. Here in the middle, you have the process, and then you have the completed work unit. So this is pretty simple. All you have to evaluate and observe is what kind of hand tools they can be using, or what is the ability of the worker to understand the process, and what is the condition of the working unit. For the machine system, what we need to observe is the conditions of the machine in relation to the worker. Sometimes the workers are not too well trained in how to operate the machine, but those are pretty much the situations, especially now that the companies have a high turnover and you have pretty much complete units that are defective, and that's pretty much for because of the worker is not properly trained on how to handle the machine. Or sometimes the work units is not in adequate conditions. We have also the automated system. In the automated system, we actually have to work on periodic worker attention. So in this case, the machine does the entire work, but you still have the need of the worker to take a look at the machine to make sure that it's not jamming or there is no issues around the equipment that is parts are getting stuck into the system, things like that. So in this case, our observation is the work unit itself. Sometimes when you have high automation, most of the problems are the material is not in good condition to be processed. So those are the conditions. Now for the definitions, a work unit is the object that is processed by the work system. In this case, the workpiece being machined by the production work, and then you have the material that is being moved. So all of this is observations, but you also have in the service industry, you have customers, not necessarily the material. So in this case, for the people that are working service environment, your customer is pretty much the material. And the product that is being designed is actually knowledge of the worker or a service. For the manual work systems, what we need to observe is the human body accomplishing physical tasks, basically. So you need to make observations, manual observations, actually working with tools or without hand tools. And some of the majority of the problems is that some companies they don't have the proper tools. So that's why in our labs is I do a lot of emphasis on utilizing our tools. And perhaps this next lab, you are going to be able to design new tools that are going to be able to make our assemblies much faster. So please bring this Wednesday, please try to bring material that's going to be able to help, tools that will be able to help accelerate the assemblies. Sometimes you may be able to bring even power tools, right? Uh, Sometimes to identify how we can minimize the eye and eye level coordination. Uh, if you have operations that use a lot of eye level coordination, that means that you're using a lot of mental effort. So anything that you can avoid using the eye coordination, that would help minimize the mental effort of the operator. Okay, so we have the manual work. It's called the pure manual work. Material handler or workers loading furniture, dealer at a casino or office worker filing documents, and typically of assembly workers just putting two parts together. Again, for the manual work with hand tools, you need to look at the machinist using a tool such as filing a part, or assembly worker using a screwdriver, or a painter using a paintbrush. So in your observations, you want to try to observe what kind of tools that they're using, or what kind of tools are they up to, technology of the tools that they're using. And sometimes your job as an engineer is to find the proper tools. Or sometimes you go to a company where they be using the tools for the last 25 years and they have now really upgraded the tools to do the work. So your job again is to investigate the tools that are necessary to do the job better. The case of an inspector using a micrometer, right? Now there's machine vision systems that you can actually put the parts, and the machine vision system can give you the dimensions automatically for the part that you're measuring. Sometimes related to material handling, and in pretty much companies that are not high tech, they still use a dolly. Whereas probably your new design might be into establishing a conveyor system between two workstations or between two departments to eliminate the use of a dolly between workstations. Okay. In this case, you also want to see, hey, there's a worker writing on a piece of paper utilizing a pen as a tool, but in reality, maybe you don't need this worker to start writing with a pen. So those are the observations that you may need to have when conducting work improvements. The other thing is things that are repetitive versus non-repetitive, right? So the things that are repetitive usually have a short-term duration. So meaning that the cycle time is really within minutes or seconds, right? Now, that means that there's a high degree of similarity between one cycle to the next. Like when you were doing the assembly of the solar system, I mean the transmitter, solar transmitter, it was kind of similar to do one versus another one. So it's just a repetitive cycle. Now, there's also the non-repetitive cycles that you need to be aware and observe and make notes that take a little bit longer time, such as when, let's say, when an operator is assembling the transmitter, then the operator needs to go and step out of his chair or his work center and walk to the shelf to retrieve more material handling parts. The other is called the OBM, and we already start to use this concept in our last lab, trying to find the one best method. So, in all your analysis, your best analysis, our goal is to minimize the time and effort required to accomplish the task. Okay, so that's the primary objective in the work design, is to determine the one best method. And then the next challenge, once you come up with the best method, is to make sure that everybody start to use the same method. In other words, we standardize it, make sure that it's a standard and everybody follow the same recipe. Another of the things that we will be discussing is our cycle time variation. So this coming lab, we will see the difference between you and other person within your team doing the same process. So we will find out what are the difference in terms of time, and we're going to talk about the variations of your method, right, between hand and the body motions, or mistakes that you probably have done, inefficient methods done by the operator, which is you. And the other one is variation in standing work units. Some of you, I noticed that started to work right away. Some of you waited until you have all the 5 components. So you start to use different methods for assembly, right? So, and there's certain movement of work that you start to do that not necessarily follows being close to each other in proximity, right? Now, there's also difference among the workers, meaning you. What is your difference when you start to use the method, and then you can start observing that, oh, my team has different ways to assemble the solar transmitter. And then the other one is the learning curve in the time, which means is if this is the first exposure to doing an assembly, your first time obviously is going to take a long time. But guess what? You start to do 3, 4, 5, 10, 100, then you start to dominate pretty much where everything is positioned, and you require less mental effort to assemble the entire unit. The case of worker performance, uh, that is something that in our software we need to enter this information. What was the performance of the operator? So that's one of the big questions, because whatever you observe, the person may not be at 100% performance. In fact, some studies mention when you start to observe somebody, they either do two things. They either do and accelerate the process, make it look like that person is doing so fast, or you may have the opposite effect. They may start to slow down. Okay, so those are the two things that you as an observer may start to do. Seeing people that are very slow or seeing people that are very fast. Okay, but then you're going to be able to distinguish which people are really above their performance. And then we're going to see what are the benchmarks to really evaluate when we call person is above or below their performance. So for normal performance, we're going to put an example such as walking 3 miles per hour. So when you work is really at a speed of 3 miles per hour, that is considered normal performance. Okay. And then you have what is called the formula to come up with the what is called normalizing the time, which means is the TC is the cycle time that you observe doing the work, and the PW is the observed performance of the operator. Okay, so what does that mean is, let's say that you're observing an operator that is working and it takes 10 seconds, right? But the performance that they do is really 90%. They kind of went a bit slow. So that means that the normal time, I'm going to put a formula here, 10 seconds times 0.90, which is 90% of their efficiency. That means that really is not taking, it should not take 10 seconds to do the operation. It should take about 9 seconds. And it can be also the opposite, right? Let's say that that person is taking 10 seconds, but it's really going above their speed. Let's say they're going to 110%, right? 110%. So that means that what you're going to do is just going to multiply 1.1 times your seconds, right? So those are the different ways that you can calculate or adjust the performance of the operator, all right? So in this case, if you multiply 10 by 1.1, it's not going to take 10 seconds to do the operation. It's actually going to take 11 seconds. So this is now you're trying to adjust to a normal time. Sometimes people go too fast, sometimes people go too slow, and these will adjust you to normalize the time, right? So let's see. Let me erase this formula. So I guess you got the idea how to utilize this formula when you can just add more time or subtract time what it should be taking. And then this is another observation, okay? The average time you to drill a hole was 10 minutes, okay? So the supervisor mentioned he was working at 90% of performance. Determine how long it should take at a normal performance and how long it should take if he was working at 110%. So in this case, we're gonna have our TC, right, which is 10 normal cycle time, our observed cycle time, which is 10 minutes. And then we have the performance of the operator, which is 90%, right? So now we use the formula. Our normal time is going to be equal the observed time, TC, times the performance of the worker. So in this case, it's going to be 10 times 0.9. It's going to be equal to 9 minutes. Okay. So this is one way that we can estimate really what will be the normal time. So in this case, the normal time is not what we observe 10 seconds, is actually we need to adjust for the performance. Now, what if we have the opposite, right? What's happening if we have a observation time of 10 minutes and then we have a partner that took, let's say, 110%, okay? Let's say that your performance was at 110%. So now, in order to calculate the normal time, we're going to use the observed time times the performance of the operator, which is 10 minutes times your 1.1. So that means that the operation should be taking around 11 minutes. Okay, so hopefully this example you're able to understand and calculate how can you adjust the observed time to what is called a normal time by using the performance of the operator. I usually, to avoid having these observations, I usually ask the supervisor, hey, can you give me someone that is qualified, that I don't have to train or they just join the company? It needs to be someone that you are confident that the person is going to do the job. Okay, so let's take another example of a man who works in the morning for health and fitness and takes about 1.85 miles, and typically time is about 30 minutes. So the benchmark for normal performance is 3 miles per hour. Okay, that's how it be. So the question is, how long the route will it take to do the normal performance? And also the man's performance when he completes the route in 30 minutes. So in this case, we're going to calculate the how long the route will take. So, okay, and also what will be the performance when he completes the route in 30 minutes. So let's walk to this example. So let's say that at 3 miles per hour, right, and is equivalent to put at 1.85, so it's about 37 minutes. So in reality, his usual route is 185 miles, but guess what? He is actually, the benchmark is 3 miles an hour. That means that he probably was walking pretty fast because it usually takes 3 miles an hour. Okay. So, and let's see. So if the typical performance is 3 miles an hour, that means that in half an hour, you're going to be able to transport milk. Okay, so now let's take a look at the calculation. Since the person was working 185 miles instead of 3, so all you have to do is to divide, and that means that 0.185 divided by 3, he actually was around 61, about zero point 0.6 hours, which is 37 minutes. So 37 minutes divided by 30 minutes, which was the usually typical time, that means he was actually walking 123%. Okay. Now we have the other option. How about if the person is walking 185 miles in half an hour, right? That means that now he's working at 3.7 miles an hour. So 3.7 miles an hour divided by 3, his performance is really 23%. So you can find, based on these examples, what is the performance of the operator. Okay. So for the case of this example, the normal performance takes in consideration the adjustment of the speed. But now let's talk about the standard performance. The standard performance is taking your normal performance, but now we're going to take in consideration that when we calculate how many pieces you can do in an hour, I mean, you're not a robot. You don't just clock in into the company, start to make parts like crazy. You're gonna have sometimes breaks. Sometimes you're gonna have to go to the bathroom. So, or talk to somebody, right? So at this case, what we call this is now we need to adjust your normal observation of time, and we need to add the periodic rest that must be taken. Okay. So there's federal laws here in California that by mine mandated you need to take 2 10-minute breaks, right? But some companies they don't even know that the breaks is just one thing, but they also have to go to the bathroom. So people take breaks, but also during your work hours, you need to go to the bathroom sometimes. So, and then sometimes you may have interruptions from coworkers or supervisors, right? And for that, we're going to call what is called an allowance. For that normal time, we're going to add an allowance for personal time, such as going to the bathroom breaks. We can find another one that another situation maybe is because I am tired, right? So, or the other one is related to the delays. The delays is the interruptions. Okay. So usually for a person that is sitting a lot of time, right? You have to give them some more minutes for production. So for that, let's go to an example, and this is the formula. So for the normal time, again, we're gonna add an allowance, right? Allowance, and this has had allowance. So the standard time is equal to the normal time multiply by the multiply, this means this parenthesis, by the allowance factor. Okay, so the PFD is stands for personal fatigue and delays. All right, guys, let's take a break at this point and we'll come back later. Okay, so now in this case we have an example dealing with standard time. So in this case we have the normal time to perform the regular cycle is 3.23 minutes. And then we have an irregular work element that it takes 1.25 and is performed every 5 cycles, which means 1/5 to calculate for each cycle, then it's going to be 1/5 of 125. So these two, you have the regular cycle plus the irregular work cycle. So all of these we are going to multiply by the 15% allowance. So out of these two, we're going to allow a 15%. So the question is, determine the standard time and the number of work units produced in an 8-hour shift. Okay, and typically 15% allowance includes rest periods, breaks, going to the bathroom, and things like that. So let's now take a look at the example on how we calculate that. So like I said, it was 3.23. This is the normal cycle. And like I said, it was going to be 1/5 of 125 because this is the irregular cycle that are performed every 5 cycles. So now we need to divide 125 divided by 5. And then we get the total normal time. So for the normal time, we just need to add a 15%. It's like going to a restaurant. You want to give a 15% tip. In this case, we just multiply 3.48 by 1.15, and the result is 4 minutes. But now the question is, how many work units are we going to produce in an 8-hour shift? So 8 hours times 60 divided by 4 is 120 work units for 8 hours. So that will take care of the quantity produced in 8-hour shift. All right, guys, so in this case, you learn how to use the normal time, how to use the regular cycles, the irregular cycles here. You learn how to apply the allowance, add an allowance of 15% to calculate the total standard time. Right, so now let's also learn about the common measures of productivity in use in an industry. They call it standard hours. So you're gonna go to companies and financial department, they actually calculate the standard hours that's supposed to take to produce a product. So what they do, they use the quantity that they produce in a given shift, in a given week, and they multiply by the standard time, and that's how they calculate the total standard hours. And pretty much that's how cost accounting departments use to calculate the worker efficiency. They use the hours standard divided by the shift hours worked. And that's how they calculate the efficiency of the worker. Okay. Now, this is why the measure of a standard time is so much used in the industry, and you as an engineer, they're going to ask you to provide this information. How many uh, are the standard hours they're supposed to be making versus the actual. So standard versus actual. Okay. So for now, let's take a look at the worker machine system. Well, this is just the same thing. Is you're dealing with manual and machine operation, such as machining a milling machine or a construction worker operating a drill or a truck driver or a worker crew working in a rolling mill or a clerical worker entering data into a personal computer. Okay, so those are the examples you may be exposed, and then you have humans on one side and you have machines on the other side. So you have sometimes power equipment, power drills, chainsaws, mobile equipment, or stationary power equipment. So this is some of the classification of power equipment, power tools, mobile and stationary. Okay. Now for the number of workers and machines, you need to also take into consideration the allowances. So in this case of an operator, right, you have a full-time attention, you have welders, but sometimes you have a part-time attention during the work cycle, such as a worker loading or unloading a part in a machine, right? And sometimes you maybe have periodic attention, right? So all of these, this is the attention levels for the operators, and it's depending on the type of equipment. This is an example of two welders working on arc welding equipment. So for this, the cycle time analysis, now you need to find out what is the manual work time and what is machine work time. Okay, so let's say in systems where the machine time depends on an operator, then you have the carpenter using a power saw to cut the lumber. So the analysis is same for manual system, is the time that it takes to handle or prepare the power saw and the time that it takes to actually do the cutting. Okay. And for that, when you have manual work time and machine work time, you have some times where the worker is busy and the machine is idle. And sometimes you have the opposite. The machine is busy and the worker is idle, right? So now the normal time, to calculate the normal time, you're going to have the normal time of the operator and the normal time of the machine. So now the standard cycle time, where you have a combination of worker and machine, you're going to add the allowances of the manual work, right? And the allowances of the machine. Now the machine have allowances because they sometimes do not work all the time. They have breakdowns, they have interruptions, they have jams. So you're going to say that not this machine is working all the time 100%. Therefore, you need to come with an allowance. Okay. And for that, we call it the internal work element. Okay. The internal work, okay, when you work with a piece of equipment, is when the machine is running. Again, I repeat, the internal work element is when the machine is running or is performed simultaneously with the machine cycle. Okay, so that's what it means. And the external work element is performed sequentially with machine cycle. Okay, which means that while the machine is running, you can do work sequentially while the machine is running. Okay, now we have the automated work system. Is the automation is the technology by which a process or procedures is accomplished without human assistance. So you may be involved in automating a manual process, and you may be finding a robotic equipment, or you may finding a CNC machine which can do the drills automatically, and you may be involved into coming up with a program and instructions for the robot control systems to execute those instructions, right? And there's different types of automation systems. You have a semi-automated, where the portion of the cycle is performed under a program and the human worker attends the machine for the rest of the cycle, right? But in this case, at a semi-automated machine, you have an operator that must be present all the time. Or you may be involved to design a fully automated system where the operator, okay, where there's no interactions with the machine and the human. You have probably just someone just to watch the machine that is working, but it's not necessarily uh, occupy the person to be executing the process. So you have a full automated machine that can, let's say, the gluing of paper, it's on a roll and it's automatically going and gluing the paper with each other, or you have a roll of steel that's coming out of a steel processing facility, or you may have an extrusion process for plastic that is continually processed. So that's a fully automated machine that continuously run and makes a product. You may go into food processing that make let's say they make waffles, frozen waffles. So they are pouring waffles every time, and then go into a conveyor. So that can be examples of fully automated machine. This is an example of a robotic spot welding in a automotive assembly company. This is courtesy for motor company, but where you see the robot doing the spot welding at different parts. So again, some of you may be involved into these projects, and we're gonna have another uh, lecture just talking about automation. But for this point, this is it, and thank you very much for your attention. If you have any questions, please let me know. We're gonna go and going over the Q&A. Thank you.